Now, let's say we have a value like this, let num equals 12.5, and we want to convert it to a number. JavaScript allows us to do it like this. Let float equals parseFloat number, and we get a number 12.5. But let's try to use another method. Let integer equals parseInt number, and we get 12. So as you can see, if we parse a floating point number with the parseInt method, we will get an integer. Let's try to parse something that is not a number. parseInt Alice, and we get NaN. NaN is a special numeric value. It means not a number. It is returned when we try to convert a non-numeric string to a number, or if the mathematical operation cannot be performed. For example, a times 2. We get not a number. On the other hand, if we try to convert a string that includes an actual number in it, like 12a, this works. JavaScript provides some built-in methods for working with numbers. For example, toString. So let's declare a number, and then the result will be number toString. Let's add the result to watch, and we get a string representation of a number. Next one is toFixed. So number toFixed 2 formats a number to 2 places after the decimal point. Another useful method is called isNaN. So let's declare a name, Alice, and in the result, we want to check if this is in fact not a number. So isNaN name, and the result is true because this is not a number. Let's try adding some numbers again. So 0.1 plus 0.2 equals, and this is weird because last time I checked, 0.1 plus 0.2 was precisely 0.3, right? Computers represent numbers in binary, and while 0.1 and 0.2 have exact representations in decimal, some numbers cannot be represented in binary with a finite number of bits. Also, JavaScript uses a binary floating point format called double precision. This format can't precisely represent numbers like 0.1 or 0.2, leading to small rounding errors. This is something to look out for when you want to perform really precise calculations. Numbers also have some limits when it comes to the order of magnitude that they can represent. We can check the maximum and minimum values we can use like this. Number max safe integer and number min safe integer. When we exceed the largest possible value or divide by 0, we will get a special numeric value representing infinity or minus infinity.